Hi everyone, so today I'll be going through the recursion and financial modelling section of the 2017 Further Maths Exam 2. So for question 5, Alex is a mobile mechanic. He uses his van to travel to his customers to repair their cars. The value of Alex's van is depreciated using the flat rate method of depreciation. The value of the van in dollars after n years can be modelled by the recurrence relation shown below. So each year his van is being depreciated by $3,375. Recursion, and you know that he purchased his van for $75,000 because that's the initial value. Recursion can be used to calculate the value of the van after 2 years. Complete the calculations below by writing the appropriate number in the boxes below. So this represents the initial value of the van after 1 year, after 2 years. So basically, after one year, you know that the value of the van depreciates by $3,375 each year. So $3,375. You put it in there, and if you do that on your calculator, it'll actually that'll give you $71,625. So V2, to find the value of V2, we use the value from V1, which is 71625, minus $3,375, because we know the van depreciates by $3,375 each year, as shown by the recurrence relation. Do that on your calculator, and you'll get 68250. BI, how many dollars is the value of the van depreciated each year? So, as we calculate on this question, we can conclude that $3,375 is the value the van depreciates every year. So $3,375. BII, calculate the annual flat rate of depreciation in the value of the van. Write your answer as a percentage. So to do this question, we need to know what the rule for D is. So D is the value of how much the van depreciates every year, which is $3,375. So we know that D equals R on 100 times V0. So R would be our annual flat rate depreciation if you find for the value of R. So we know what the value of D is, which is 3,375, and we know that V0 is $75,000, so therefore we can find what the value of R is. So 3,375 equals R on 100 times V0, $75,000, sorry. Solve that on your calculator and you get R equals Solve that on your calculator and you get R equals 4.5% per annum. So therefore that's your answer. 5C, the value of Alex's van could also be depreciated using the reducing balance method of depreciation. The value of the van in dollars after n years IN can be modeled by the recurrence relation shown below. At what annual percentage rate is the value of the van depreciated each year? So you know that 0.943 is the value of this R over here, and we know the value of R is 1 minus little r on P over 100. So little r is the annual percentage rate of depreciation, and P is the compounding periods. So you should know that the formula for the reducing balance is 1 minus little r on P over 100. So therefore, if we solve for little r, which is the annual rate of depreciation, 0.943 equals 1 minus little r on P, compounding periods, we know that the value of the van in dollars after n years. So therefore, compounding periods is 1 on 100. Solve in your calculator for R. And you get 5.7% per annum, which is the rate of depreciation every year. Question 6, Alex sends a bill to his customer after repairs are completed. If a customer does not pay the bill by the due date, interest is charged. Alex charges interest after the due date at the rate of 1.5% per month on the amount of an unpaid bill. The interest on this amount will compound monthly. Alex sent Marcus a bill of $200 for repairs to his car. Marcus paid the full amount 1 month after the due date. How much did Marcus pay? So I've established over here that this would be the general rule we'll be using. So V0 is $200, and to find the value of D, we know that the interest rate is 1.5% each month. How much interest he charges each month, so 1.5%, 1.5 on 100 times 200 would be the interest like each month. So that'd be how much extra someone would have to pay each month extra to their bill if they don't pay it, if they don't pay their bill after each month. So therefore, we found that the value of D is 3, so therefore our rule is Vn equals 200 plus 3n. So let's go back to A. Alex sends Marcus a bill of $200 for repairs to his car. Marcus paid the full amount after 1 month after the due date. How much did Marcus pay? So N represents how many months after the due date. So in this question, we know that Marcus paid the full amount one month after the due date. So 1 month after the due date is V1, so 200 plus 3 times 1. That gives you 203, so therefore Marcus paid $203. 6B, Alex sent Lily a bill of $428 to repair her car. Lily did not pay the bill by the due date. Let AN be the amount of this bill in months after the due date. Write down a recurrent relation in terms of A0, AN plus 1, and AN that models the amount of this bill. So you should know that since this models simple interest, the rule would be A0 equals the initial value, comma, AN plus 1 equals VN plus or minus D. But in this case, we know that it's Alex charges interest for after every month that you don't pay your bill, or after every month that your bill is overdue. So therefore it's plus because it's interest, and therefore now we just got to find the values. So we know the initial here is $428 because that's the bill Lily was sent. So A0 equals 428, comma, AN plus 1. Sorry, this should be AN plus D. So D equals R on 100 times V0. That's the formula you should know for D. So we know that Alex charges interest at the rate of 1.5% per annum, so 1.5 times V0. V0 is, in this case, was $428, which is the bill Lily got sent, so $428. If you do that on your calculator, you will get 6.42. So 6.42. So therefore, this is a recurrence relation for the amount that will model the amount of Lily's bill after each month. 6C, Lily paid the full amount of her bill 4 months after the due date. How much interest was Lily charged? Round your answer to the nearest cent. So to make calculations a little bit easier, we'll convert the recurrence relation to an nth term relation. So the nth term relation would follow the rule AN equals V0 plus DN. We know the value of V0 is 428 and D is 6.42 from our previous question. So AN equals 428 plus 6.42 times N. So we know that Lily pays the full amount of her bill after 4 months, so A4. So N represents how many months after the due date, so 428 plus 6.42 times 4 months, and that will give us the total amount. That'll give us the total amount that Lily had to pay. So 428. So if you do that on your calculator, you'll get 453.68. And now we want to find how much interest Lily was charged. So the interest would equal A4 minus the initial value. So we know that A4, after 4 months, she had to pay $453.68 minus her initial bill, which was $428. So if you do it on your calculator, you'll get $225.68 is the amount of interest Lily had to pay. Question 7. Alex sold his mechanics business for $360,000 and invested this amount into a perpetuity. Perpetuity interest at the rate of 5.2% per annum. Interest is calculated and paid monthly. What monthly payment will Alex receive from this investment? So you should know that in a perpetuity, basically the investor receives the interest from the bank. So basically $360,000, the amount that Alex would be receiving each month is the interest the perpetuity earns, which is 5.2% per annum. Since we know Alex's monthly payments is going to be the interest the perpetuity earns, the rule would be R on P on 100 times V0, which is the value he invested, and that will give us his monthly payment. So we know that r is the yearly interest rate, or the interest rate per annum. P is the compounding periods, and V0 is how much money Alex invested into his business, into the banks. So if you do that, 5.2% for the value of R divided by P is 12 in this case because we want to know his monthly payment, and divided by 100 times V0. V0 is the amount he invested, which is $360,000. If you do that on your calculator, you'll get $1,560 as your answer. So that is the monthly payment that Alex receives from his investment. 7b, later Alex converts a perpetuity into an annuity investment. The annuity investment earns interest at the rate of 3.8% per annum, compounding monthly. For the first 4 years, Alex makes a further payment of each month of $500 to his investment. This monthly payment is made immediately after interest is added. After 4 years of these regular monthly payments, Alex increases the monthly payment. The new monthly payment gives Alex a balance of $500,000 in his annuity after a further 2 years. What is the value of Alex's monthly payment? Round your answer to the nearest cent. So if we need to calculate the future value after the first 4 years. So the annuity investment earns interest at the rate of 3.8% per annum. So 3.8% per annum. Compounding monthly, so monthly is 12. For the first 4 years, so first 4 years, 4 times 12, because 48 months, which equals 48, so 48 months is 4 years. So for the first 4 years, Alex makes a further payment of each month of $500 to his investment, so negative 500, because adding $500 to his investment. And we should know that his initial value of his investment is $360,000 from the previous question, so negative 360,000. So both of them are negative because both of them have been added to the investment. So, and then we know after the 4 years of these regular monthly payments, Alex increases the monthly payment. The new monthly payment gives Alex a balance of $500,000 to his annuity. So that's the next part of the question. So if we do this first, we get a future value of 44872.94. So that's the future. So that's how much money his investment is after 4 years. And then if we move this to the principal value, it's negative 44872.94. We know that Alex changes his monthly payment, and we got to find that out. But we know the new monthly payment gives Alex a balance of $500,000, so $500,000 in a further 2 years, so 2 times 12, which is 24 months, so 24 months is 2 years. And we know that the interest rate is still 3.8% per annum, compounding monthly, and we got to find the payment. So if you do that on your calculator, you'll get negative 805.65 to the nearest cent. So therefore, $805.65 is the value of Alex's new monthly payment.